All right, trait number 3 to getting a 500 plus on the SAT is to be able to think proportionally and be able to set up a proportion and use a proportion. So we see this in the realm of statistics and data analysis inference questions, geometry problems, and even just simple proportional word problems. And actually being able to convert with units and stuff, for instance, is kind of a skill set too. So when I teach ratio and proportion in my classes, I simply say that a ratio is a comparison between two numbers, and a proportion is an equation that equates to ratios. So pro tip is to always know what you are comparing. So for instance, a proportion problem could be if Max Jones is running for class president and receives 40% of a vote in advisory, we could think about not maybe what percentage does the vote you receive overall, but how many votes will Max Jones receive in a 800 person class, something like that. So let's take a look at some sample problems that involve this. So first type of question is called the statistical inference. So we have kind of a wordy problem here, and I like to kind of circle the question. So 60 middle school students, and of the students surveyed, 14 watch more than 4 hours of TV per day. And we have 1143 in the school district. So question is, how many students watch more than 4 hours of TV per day? So we want to think about, what are we comparing? We're looking at number of greater than 4 hour a day TV compared to total students. And in this first group here, we have 60 middle school students, of which 14 surveyed watch more than 4 hours of TV. And the question is, how many are watching more than 4 hours of TV in the school district? So I'm thinking about, am I going to put this in the number of greater than 4 hour TV row or the total? And it's asking how many are watching over 4 hours. So that's going to be in the greater than 4 hour row. This is the school district column. And on this side is the survey column. And we have 1,143 middle school students in total. So what we're going to do is we're just going to cross multiply. So you should be able to cross multiply and get what you need. So that's the good news about these problems. So when I cross multiply, I always just multiply kind of diagonally. So I'm going to do 1143 times 14. I'm going to get 16,002. And I'm going to set that equal to 60x. And I could do 16,002 divided by 60 to get me 266.7. Now you could also approximate this by saying that 14 out of 60 is approximately 1/4. And I could ask myself, what's about 1/4 of 1,000 or so? And we would see that that's maybe about 250. So 267 would be, kind of in the ballpark. Another thing that you may see on the SAT, this is a good question because, maybe it's kind of, I mean, I have no idea what rate of perceived exertion is. It's probably some type of fancy science term. But I mean, you're going to kind of run into these if you're going to be a science major, concepts like these. It runs from 0 to 20 and is approximately proportional. So this means, right, a proportion. So we could actually compare an RPE to somebody's heart rate. So the 20 RPE corresponds to somebody that has a heart rate of 205. And the question is, what's the RPE of somebody who has a 70 beat per minute heart rate? So I'm going to cross multiply. So I get 1400 equals to 205x. And I'm going to divide by 205. So I get that x is about 6.83. And it asks us to round to the nearest integer. So it's going to be about 7. So we were able to take this from, some technical science problem to, at the end of the day, just setting up a proportion and making something that we could cross multiply.